In this video we're going to interchange fractions with decimals and simplify these some expressions using the order of operations PEMDAS. Okay, so here's example 1, example 2, example 3, example 4, example 5 and 6, and examples 7 and 8. Okay, so we'll start with example 1, and we've got a quarter times 1.3 plus 3.5. So we have to simplify that. So we've got to think PEMDAS, right? The order of operations we need to remember when we're simplifying things. So really quickly, let's just write that out again. PEMDAS. This is the order of operations. The first thing we do is parentheses. The second thing we do is exponents. Then we multiply or divide from left to right, don't we? Then we add or subtract from left to right. Okay, so we'll just keep this little cheat sheet beside us so we can remind ourselves of the order of operations as we go along. Now, what should we do first on this guy? We've got parentheses, don't we? Around the 1.3 plus the 3.5. So PEMDAS says, the order of operations says, we do everything inside the parentheses first. Okay, so we add those guys together, and you can just do that on the side of the page somewhere. So 1.3, 3.5, add those guys together. When you add decimals, you need the decimal points underneath each other. 3 and 5 is 8. Decimal point goes down here. 1 and 4 is 4. So we add the tenths and then we add the units. We get 4 units and 8 tenths. 4.8, right? Now, so this is 4.8. And we have 1/4 multiplied by that. Now, at this point, you may be tempted to change the quarter into a decimal and multiply, and you can do that. You would have to go 4 into 1, you would have to turn that into a decimal, you would have to multiply. It would take quite a while. For a lot of these examples, it might be easier to work with it in fraction form, and I'll show you a quick way. So what I'm saying is, yes, you could do that. Okay, you would end up with 0.25. You would then have to go 1/4 times 4.8 would then become 0.25 times 4.8. You would have to do the long division or the long multiplication, and you could do that and you will get the right answer. There's a quicker way. Can you see a quicker way? If you multiplied by fractions, what would happen? 4.8 as a fraction can be written 4.8 over 1, right? Can you cross cancel common factors now? I guess if you want, you could write it out again. 1/4 times, 4.8 over 1, if you want to make it clear. You've got 4 on the bottom and 4.8 up here. What's this? 4 into 4 goes once. 4 into 4 goes once. 4 into 8 goes twice. And the decimal point must go here. So we've got 1.2. So this gives me, you see, 1 times 1.2, 1.2 over 1 times 1, which is 1. So of course it just gives you 1.2. 1.2 over 1 is just 1.2. So that's a quicker way. If you can see that a fraction can cross cancel easily with a number, by all means do it, because hey, it'll be a quicker way. Like I said, you could have converted the quarter into 0.25 and multiplied. It would just take a little bit longer. Okay. So try example 2 and see. There is a quick way, and see if you can find that quick way in example 2. Once again, you can convert 2/3 into a decimal. It will be a never-ending decimal though, and then multiply. You'll get the answer pretty close. But can you see some way of maybe multiplying fractions? By the way, first of all, we've got to make sure we get the order of operations right. Do we subtract to begin with, or do we multiply to begin with? We have parentheses, but there's nothing to calculate inside of the parentheses. That's already done, so to speak. So we have a multiplication and a subtraction. Which comes first? Multiply, right? So we have to multiply first. Okay. And you see, I can write that as 2 over 3 multiplied by, and this can be written 0.15 over 1, right? Just like any number, 0.15 over 1. Now, does 3 go into 15? Sure does. 3 into 3 goes once. 3 into 15 goes 3 times. Or no, goes 5 times, isn't it? But where do you write the 5? You write the 5 here, above this guy here. And where does the decimal point go? Well, it goes here. And you've got to put a 0 here now. See that? 0.05? 0.05. So it's basically, if you have 15 cents and you're dividing it by 3, you'll get 5 cents, won't you? Right? So it's now we have 2 times that over 1. So we can calculate that. Let me just get some paper here. So, you know, this is 2 times 0.05 all over 1 times 1, or 1. What is 2 times 0.05? 2 times 5 cents? Well, it's just 10 cents, isn't it? 0.10 over 1, which is, of course, 0.10, or just 0.1, right? Okay, so that's if you use the fraction, multiply by fractions once again, you can work it out to be 0.1. So this multiplication became 0.1, and so now we do the subtraction part. 4.3 minus 0.1, right? Sorry, I guess I'll leave that there. So 4.3 minus 0.1, what's that? Well, let's just calculate that. 4.3, 0.1. 3 minus 1 is 2. 4 minus 0 is 4. I get 4.2. Okay. Now, let's have a look at example 3 and 4. Example 3, 3.99 divided by a half. What am I going to do with that? Well, you might remember that it's basically this number divided by this number, okay? So we can rewrite that as 3.99 divided by 1/2, can't we? Now, what can you get? Can you take the next step on that? What's the next step? That's the same thing as multiplying by what? Flip it upside down. 2 over 1. So it's the same thing as 3.99 multiplied by 2 over 1. Now what's 2 over 1 anyway? Now maybe I should put parentheses for multiply, right? 2 over 1 is 2. So 3.99 times 2. Okay, we can do that, can't we? Multiply. 2 times 9 is 18, carry the 1. 2 times 9 is 18, and 1 is 19, carry the 1. 2 times 3 is 6. 6 and 1 is 7. What do I do with my decimal point? I have 2 decimal places in the problem, so I'm going to have 1, 2 in the answer. So multiplying decimals, I get 7.98. Right? Let's have a look at example 4. 2 over 7 times 0.4 plus 5 over 7 times 0.4. You know, if you really wanted to, you could turn 2 sevens into a decimal. You'd have to go 7 into 2.000. That would take quite a while. Then you could multiply this decimal by 0.4. And then you could calculate this as a decimal and keep going. But an easier way might be to turn the 0.4 into a fraction. So, by the way, please write out this question and do it, please. So you would have 2 over 7 times 0.4 over 1. Does anything cross cancel? No. But hey, that's not a big problem because I'll just multiply the tops. I'll multiply the tops. 2 times 0.4 gives me what? 2 4s is 8, 2 zeros is 0. 1 decimal place in the question, 1 in the answer, so that's going to be 0.8, isn't it? So if I just multiply it across, I get 0.8 over 7. Now please press pause and do this one. Please do this one yourself. 5 over 7 times 0.4. What do you get there? Please do this one yourself, just like I did the first one. Okay, what you're going to turn 0.4 into a fraction. 0.4 is 0.4 over 1. Now multiply the fractions. Just multiply the tops, multiply the bottoms, right? So we got to go 0.4 times 5. 5 4s is 20. 0, carry the 2. 5 zeros is 0 and 2 is 20. And it's 1 decimal place, so 2.0. So I basically get 2, or you can even write 2.0, whatever, over 7 times 1 is 7, right? Now, what does that make? 0.8 plus 2.0 all over 7. Well, let's see. 0.8 plus 2.0 gives me what? 8 tenths and 2 units, right? So if I have the bottoms the same, can't I add the tops together, right? 0.8 plus 2 is 2.8 over 7. So I've got 2.8 over 7. Can't I divide that and get the answer? So what do I do? What into what? Go further. You can go further with this, can't you? 7 into 2.8. Okay? So what do you get? 7 into 28 goes how many times? 7 into 28. 7 into 28 goes 4 times, and you must write the 4 above the 8. The decimal point goes here, and you must put a 0 here as well. So the answer is 0.4, isn't it? Let's have a look at example 5. 3/8 plus 0.35 times 3/4. Now, I guess I wonder, what does it help to multiply the fractions across this time? I suppose it might. What difference would it make, right? I guess if we keep doing the same thing, it might help. So we don't get too confused. So 0.35 is 0.35 over 1, right? If I multiply across, I'll get 0.35 times 3. 3 5s is 15, carry the 1. 3 3s is 9. 9 and 1 is 10. And I have 2 decimal places in the question, so 2 in the answer. 1.05. Oh, by the way, of course, thinking about PEMDAS, we can't add to begin with, can we? We have to multiply first and then add, right? So in any case, 0.35 times 3 becomes 1.05, and on the bottom I have 1 times 4, which is 4. Okay. And then of course I have 3/8. So I have 3 over 8 plus 1.05 over 4. Okay. And I guess we will just have to, the answers have to be in decimals in the end. So we guess we'll just have to turn each one into a decimal, right? So 3 over 8, we've got to go 8 into 3. Right, and then on this one you've got to go 4 into 1.05. So please press pause and do both of these divisions and see if they get the same thing as me. Okay, I'm going to do them pretty quickly now. So please press pause and try them and then see if you get the same thing. Okay, 3, 2, 1, I'm going to do them now. So 3 should be written 3.000. 8 into 30 goes 3 times. 3 times 8 is 24. Subtract and I get 6. Bring a 0 down. 8 into 60 goes, let's see, 7 times, right? 7 eighths is 56. Subtract and I get 4. Bring a 0 down. 8 into 40 goes 5 times. 5 times 8 is 40. Subtract and I get 0. Okay, so the decimal point goes up here. So this becomes 0.375 plus this guy. 4 into 10 goes twice. 2 times 4 is 8. Subtract and we get 2. Bring the 5 down. 4 into 25 goes 6 times. 6 fours is 24. Subtract and we get 1, and we need to add on another 0 onto this guy, don't we? You can keep putting as many zeros as you like. I'll put a bunch on. How about that? Bring down one of those zeros. 4 into 10 goes twice. 2 fours is 8. Subtract that. We get, we get 2, right? Bring down a 0. 4 into 20 goes 5 times. 5 fours is 20. Subtract and we get remainder 0 at last, right? So this guy became 0.2625. Okay? So what I have is 0.375 plus 0.2625. Okay? So if I add those guys together, I'll get my answer. So 0.2625. And if I add decimals, I must put the decimal points underneath each other because I'm adding tenths with tenths, hundreds with hundreds, and thousands with thousands. Okay? And I can stick an extra 0 onto this guy for a 10,000th placeholder. So 5 and 0 is 5, 2 and 5 is 7, 6 and 7 is 13, carry the 1. And that gives 6, and then we have this. So 0.6375 is the answer here. Okay. Another way to do this question you might have thought of is, well, why don't I just convert the 3/4 to 0.75, which 3/4 is 75 cents, right? So you got 0.35 times that. You could multiply these out if you want to, and eventually you will end up with getting 0.2625. So that would probably be an easier way. So to calculate this is just multiply these out. 0.2625. You could have done it that way as well, right? Okay, let's have a look at example 6. We've got 1/4 all squared times 7.2 plus 1/2 to the power of 3 cubed times 4.8. So we've got to consult with our order of operations again to see what we do first here. Do we have anything in parentheses that needs to be calculated inside the parentheses itself? No, right? I mean, the 1/4 is fine, the 7.2 is fine. There's nothing in parentheses that needs to be calculated, so we're okay for that. Do we have any exponents? We sure do. 1/4 squared and then 1/2 cubed, right? So we've got to do exponents. So let's do that. 1/4 squared. I guess I'll just do it on a side of the page or something. 1/4 squared is 1/4 times itself. If the squared is touching the parenthesis, it means parenthesis times parenthesis. So it's 1/4 multiplied by 1/4, which gives 1 times 1 is 1, 4 times 4 is 16. So this becomes 1/16. Then we have times 7.2. Then we have plus, and we must also do the half to the power of 3. Okay? Okay, that's another exponent. So we have to do all our exponents. So 1/2 to the power of 3 is the thing times itself 3 times. If it's power of 3, touching a parenthesis, it's parenthesis times itself 3 times. So it's 1/2 times 1/2 times 1/2. And remember, always write your fractions, don't write your fractions like this. Because if you're doing that, it's kind of hard to multiply them, isn't it? If you write them like this, it's easy to see that you multiply the tops, then you multiply the bottoms. 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8, right? So the 1/2 cubed simply became 1/8 times 4.8. Okay. Now, once again, at this point, we could turn the 16th into a decimal and turn the 8th into a decimal and calculate everything. But you might see it a little bit simpler to simply turn the 7.2. See, I think 4 might go into both of these at least, right? If you turn the 7.2 into a fraction, 7.2 over 1, and cross-cancel common factors, it might work out nicely, you see. By the way, the next thing we do with PEMDAS, so we've done exponents with PEMDAS, now we have to multiply, right? And then we add. So multiply and then add, right? So we're on to multiply. Okay, so, but look, 4 will probably go into this, won't it? 4 into 16 goes 4 times. 4 into 7 goes once. Remainder 3. 4 into 32 goes 8 times. And the decimal point goes up here. So that's 1.8 over 4. Does that simplify it even further? I think so. 2 into 4 goes twice. 2 into 18 goes 9 times. 0.9 over 2, or 0.9 over 2, right? And then we have to figure out the other guy. Well, you can write 4.8 as a fraction, 4.8 over 1, and then cross-cancel common factors. Does 8 go into 48? 8 and 8 goes once. 8 into 48 goes 6 times. And the decimal point can go right here. See that? So this guy becomes 1 times 0.6, 0.6 over 1 times 1, 1, which is 0.6. So now we have the multiplications figured out to here and here. Of course, next thing we have to do is divide and then add, right? So 0.9 divided by 2 shouldn't be too bad to figure out, right? That's just 2 into 0.9. You might need some zeros. 2 into 9 goes 4 times. Remainder 1. What's 2 into 10? 5. And the decimal point goes where? Right here. So 0.45 or 0.45. So that's 0.45 plus 0.6. So I've got to add these guys together. 0.45, 0.6. Make sure you put the units over the units, the tenths over the tenths, and the hundredths over the hundredths when you're adding. Okay? And you can put a 0 placeholder for this if you like. 0.6 is just like 0.60, right? 5 and 0 is 5. 4 and 6 is 10. Carry the 1. And this is 1. And the decimal point goes here, right? So we get 1.05. Okay, last example, 7 and 8. The trick with these, by the way, is if you can see what type of fraction 0.75 is right away, that might work out. So just from our experience, I hope we might just remember, how many quarters is 75 cents? I mean, if you want, you can go 0.75 is 75 over 100, and then put it in lowest terms. 25 into 75 goes 3 times, 25 into that goes 4 times, so we get 3/4. And if you did that, then the whole thing becomes a little bit simpler, because look, you have 3/4 squared minus 1/4 squared times 5, and so you're just dealing with the same types of fractions. But anyway, you might just remember that 75 cents is 3/4, so you can just write that in there right away. Okay, so if we go to figure this guy out, alright, if we go to figure this guy out, we've got to think of PEMDAS. So the first thing we do is parentheses then exponents. So we got to do our exponents next, right? So 3/4 squared is, let's do that, is 3/4 times itself, isn't it? What does that give you? 3 times 3 is 9, 4 times 4 is 16. So here we have 9 over 16, right? What's 1/4 squared? Can you do that one? 1/4 squared is, so we've got to do our exponents. We're doing our exponents because of the order of operations PEMDAS, right? 1/4 squared is 1/4 times 1/4, which is 1 times 1 is 1. 4 times 4 is 16, right? So 1/4 squared becomes 1 over 16. And just fill in the rest of the problem now. So it's minus that times 5. Now, can you write the 5 as a fraction? 5 as a fraction is 5 over 1. Now if I multiply these fractions, I get 1 times 5 is 5. 16 times 1 is 16. Nothing cross cancels, right? So I have 9 over 16 minus 5 over 16. Or in other words, 9/16 minus 5/16. How many 16ths does that give? 4/16, right? And does that simplify? Can you put that in lowest terms? 4 into 4 goes once. 4 into 16 goes 4 times. So this becomes 1 over 4. So the answer is 1/4. And if you want to write your answer as a decimal, you've got to turn 1/4 into a decimal, right? So you've got to go 4 into 1. And we know how to do that. You write the 1 as 1.000, and then you go ahead and divide it in. 4 into 10 goes 2 times, remainder 2. 4 into 20 goes 4 into 20, 5 times. And the decimal point goes up here, right? So it's 0.25. So 1/4 is 0.25. Or you might just remember that. $0.25 is 25 cents. I mean, let's remember some of these, right? So the example A, please try this yourself. And I'll just give you one tip. Try to first convert the 0.25 into a fraction. 0.25 is what fraction? Oh, we just got it, didn't we? It's 1/4, right? Okay, so now press pause and do the whole thing yourself and see what you get in the end. Then I'll do it. Okay, did you try it? I'm going to do it now. Hope you tried it. So 1/4, we've got to do the exponents first because of the order of operations PEMDAS. So we'll do 1/4 squared is 1/4 times 1/4. 1 times 1 is 1, 4 times 4 is 16. So this becomes 1 over 16. And of course I have 1 over 16 times 7. Now I'm going to see that, look, I'm adding the same type of fractions here, really, haven't I? So what I'm going to do is turn the number 7 into 7 over 1. And then I'll have 1 over 16 plus 1 times 7 is 7 over 16 times 1 is 16. So it's 1/16 plus 7/16. How many 16ths? 8/16. Can I put that in lowest terms? Yep. 8 and 8 goes once, 8 and 16 goes twice, so I have 1/2. Can I write that as a decimal now? Write that as a decimal. 2 into 1, or 2 into 1.00, right? 2 into 1 won't go, 0 times, decimal point goes up here. 2 into 10 evenly goes 5 times. 5 times 2 is 10, you can subtract, the remainder is 0. So it's definitely 0.5, isn't it? So the answer is 0.5.